Okay, on the sampling lab, we had gotten through the first one and the second one. Well, we had taken a convenience sample, and I had you tell me why you took each one that you did. Everybody sign? Anybody miss it? And then we did a simple random sample using command randint 1,34, and we randomly chose students from the group. Then we did a systematic sample where you randomly chose, knowing that there's 34 students, you numbered the students 1 through 34, and then you randomly had to select a starting place. So since you're randomly selecting a starting place, then you use randint 1,34 to pick one of these kids to start with. And then randomly generated a number between 5 and 10. And then beginning with whatever student you started with, let's say we started with this one, and your random number between 5 and 10 was 6, then we randomly started here. This was the student where we started, and I'm going to assume that I numbered in order. So this would have been the first student 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And when you had 8 students, you stopped. So let's see, that would have been 1, 2, 3, 4, 5, 6. And I believe that would have made 8. 1, 2, 3, 4, 5, 6, 7. Nope, need one more. So 1, 2, 3, 4, 5, 6. We would have chosen that student for systematic sample. And then we did cluster sampling, which means you numbered the groups 1, 2, 3, 4, 5, and you randomly chose 2 of the groups. Let's say I chose group number 2 and group number 5. And I would have taken all of group 2 and all of group 5, which means that I had a sample of, let's see, that would have been 7 students, and 6 students would have been 13. Whereas if I had chosen groups 1 and 4, I would have had 7 and 8, which would have been 15. Or if I chose group 4 and 3, that would have been 14. So I could have gotten different sizes, but the key here was that I would have been choosing some of the groups. That would have been different from stratified, where I would have chosen some from every single group. I would have numbered these students 1 through 7 and chosen a random number between 1 and 7. Let's say I would have chosen student number 4. And then I would have randomly chosen again 1 through 7, and maybe I chose student number 2. And actually I would have been taking a sample of 3 from each group, and I'm just taking 1 from each group. And then I would have chosen 1 through 6 because there's only 6 on this one. And I would have chosen, let's say, student number 6. That would have been that one. And then here I have 8 students, so I would have chosen 1 through 8. And maybe would have come up with student number 3. And then here I would have gone 1 through 6 and maybe chose student number 4. So I would have chosen one or some from all. That's the difference between those two samplings. So if I were to have done that, the questions we want to answer, and I hope you already answered these so that you can discuss them with me. The questions we would want to answer are, which two samples require that the school be broken up into groups? What kind of sampling methods? Stratified and clustered. Which sample required that some be chosen from each group? That would have been stratified. Which sampling method required that all be chosen from some of the groups? And that would have been cluster. Does stratified sampling require that the same number be taken out of each group? Well, the way that we did it, we were told to take a certain number out of each group, but we have to.
I was confused by that.
Okay, it does require that some be taken from each group, yes, but the same number, no. Suppose, for example, that I were to divide the students in this room up between people that were taking more than 12 credit hours and students that were taking less than 12 credit hours. How many of you are taking 12 credit hours or more? How many of you are taking less than 12 credit hours? Okay, I only see 4 students that are taking less than credit hours, less than 12 credit hours. So, would it necessarily have to be that I chose the same number from the students that are taking less than 12 credit hours and the students are taking 12 or more credit hours? Do I need to take the same number from each group and actually get a representative sample? No, because only 4 of you are taking less than 12. So I would want to take fewer from that group and more from the group that are taking 12 or more. So does it require the same number from each group? No. Same thing if you were dividing people up among people that have different majors. You might want to take a different number of groups from different majors, depending on which major has the most students in it. You might want to divide it up among male and female. You might want to divide it up among people that are University Parallel students as opposed to people that are Associate of Applied Science students that are going to get the degree and go to work. You're all going to get a degree. But some of you are going to get an associate's degree and go on and get a bachelor's degree. Some of you are not. So, if I want to represent the group fairly, I probably want to make my sample proportional to the size of the group that has that characteristic. In which sample did every possible sample of 8 students in the school have an equally likely chance of being chosen? Only with simple random. Because when we did cluster sample, there was no guarantee we would get a group of 8. When we did stratified, we got a group of 8. But that was because we were told to keep going until we got a group of 8. And depending on how we actually started, we might not have gotten a group of 8. If we did a convenience sample, yeah, you got a group of 8, but not every student had an equally likely chance of being chosen because you were, whether you intended to be or not, you were biased in your choices. So the only one that guaranteed every possible sample of 8 students in the school had an equally likely chance of being chosen was simple random. Now, the systematic came close, because you randomly chose the starting point and then you randomly chose the increment and then went through until you got 8 students. But the thing about that is that some of you had to go past the starting point and some of you didn't, depending on what increment you chose. So for stratified cluster sampling, the groups chosen were the classes. Is there another way all the students in the group could be grouped? Well, let's look at this. I think we did talk about this, but let's just look at this card. There's a color picture of the kids. In fact, I'll make it a little bigger. I wish I could get this to go away. There. Let's make it a little bit bigger so we can see them even just a little bit better. What other ways could we have grouped these students instead of just by their classrooms?
Boys and girls.
Okay, that's the obvious one, boys and girls. What other kind of groups?
Things with wheels, things without wheels.
Things with wheels, things without wheels. Kids that were being active, that were doing sports, so to speak.
Long hair, short hair.
Long hair, short hair, different color clothes. All the ones that had pink outfits on as opposed to the ones that had red outfits or blue outfits or yellow outfits or whatever. So you can group them up all kinds of different ways. It doesn't have to be by grade or even by class. I mean, we could assume that these were, Mrs. Smith and Mr. Johnson was 3rd grade, and Ms. Carey and Mr. Gregory were 4th grade, and Ms. Turner was 5th grade. We could have grouped them up that way. So there's a lot of different ways we could have grouped those students up.
Did we have to put all those, or?
No. Just the idea of, why would you choose to group them up a certain way? And it would depend on what it is that you wanted to look at, what your survey question was that you wanted to get answered, as to which ones you would have chosen. So does anybody have any questions about the sampling activity now? You understand sampling methods. You will be required to know what the sampling methods are on the test. I'll propose a situation where somebody's chosen a sample and explain how they take the sample, and I'll probably ask you which sampling method did they use. So you need to be able to identify those. Questions about anything else before we go on?
Is there a place where we can go over that and rewatch? Is there a way we can get the media assignments to rewatch them?
Sure. You can get the media assignments when you actually get into D2L and MyLabs Plus. Too many passwords. Once you've actually already done them, when you go back into your homework, it's not going to make you go to them again because you've already done them. But if you want to find them, if you will click on I think it's assignments. In chapter 1.
Like there's a place in, like if you go to the main menu and like whether you're
Yeah, there's a place that you can do it.
like it will say view all assignments. It'll have the media assignments all the way down.
Yeah, I think actually if you go to Gradebook and you go to your Gradebook, like this is my Gradebook, it shows you the media assignment for chapter 1 and then it shows the chapter 1 homework because I've actually done those when we started in the class. So you need to just go to where your Gradebook is. And then everything you've done, if you want to review the media assignment, see, I've only got a 2.7 out of 8 on that. So if I want to review the media assignment, I just go click back on the media assignment, and I can look at the different ones that you have to do.
We have seen that introducing random elements in the form of random sampling or by randomization in an experiment reduces bias, and that estimates settle down as the number of observations grows. Both of these conclusions help us to extend our understanding from the data at hand to the population at large.
Well, maybe I'll show you.
This extension is
There we go. So some of these are one type of video. That one was an interactive assignment. It'll actually want you to answer questions during it. But the ones that have the little blue boxes are the ones that have the lady that's talking to the student.
She hurts.
Hi, I'm Dr. Debbie Oak from
Too
Duke
chipper.
University. And today we will be talking about ideas
So there's two different kinds of media.
Sample data are not collected in an appropriate way. Data may
So yes, you can review the media.
Is there a reason why it says media assignment for chapter 6, chapter 8, chapter 9, and chapter 10 is overdue?
Probably because I haven't actually put the right due date on them yet. I mean, we're not to those chapters,
That's
obviously.
what I was
Yeah, don't worry about those. I actually created all the media assignments. Not all the teachers have the media assignments because I knew that sooner or later it would snow. I just didn't figure it would be during the first week of class. So I put the media assignments in there so that you could stay on track. You could actually work from home by watching the media assignments and then do your homework. And then we would still have a chance to go over it in class. But it was there as kind of a help. And I made it prerequisite to doing the homework so that you would at least know where they were, that you would see what was available there. But don't worry if it says a media assignment is overdue because I'll adjust those as I go along. I just made them all over the course of a couple of days and it just defaulted to the days that I made them. Okay? So yeah, I'll fix all those due dates. Don't worry about those. Any other questions before we go on? Okay, what I want to do right now, and I will tell you all this, do not print out the Chapter 1 crossword puzzle if you haven't already. Don't print that out. You are not required to hand that in. You are not required to do it. I have a similar activity that we may do on Wednesday if we have time that is not a crossword puzzle. It is actually a bingo type game that reviews the same information. If we have time, we'll do it that way. But that's not going to be a graded activity, so don't waste your print money printing that out. We're probably not going to use it. And the reason I left that there was because I had put it in originally, and then I got this other activity from another teacher that reviews the same thing that I think would be a lot more fun if we have time to do it. So don't worry about doing that. Okay, we were in Chapter 2, and we were working on the notes for Chapter 2 with examples. As I remember, we did not get finished. Is that correct? It's been so long. We got through most of it. We didn't get through, I remember doing the pie chart.
Yeah, the pie chart was the last thing we did.
Okay.
You said-
Well, the pie chart is actually the last thing of the whole thing.
Yeah, that's why I thought.
Okay. I just wanted to make sure that we actually got done with that. What I want to do, and I am, hang on to Chapter 2's notes because we're going to come back to those in a few minutes, to kind of introduce Chapter 3. I'm going to give you an activity to work on between the first half of class and second half of class. Make sure you understand the difference between pie charts, Pareto charts, and histograms. We've made all of those up to this point, but we have not made them in Excel. So what I would like to do right now, to kind of wrap up Chapter 2, is I would like to go into Excel, and I'm going to take the Old Faithful worksheet, which actually you would have already had a chance to work on it. Actually, actually, rather than get it from there, I'll get it out of my Dropbox because it prints faster that way.
We're gonna turn in these, sample sheets.
No, those are for you to learn the methods. I don't take up some of those sheets. Some of them I do. I'll take in advance. I'm going to take something out. Now, I am going to do the Old Faithful worksheet with you here in class, but I expect you to do the other two as homework, and I probably will take up both of those. Two is there only one. Sometimes I take some up now. I'll probably take up the Disney movies worksheet. The drawing grass worksheet, I'll let you know if I'm going to take it up or not. So I'll probably take up the Disney movies instead of, let's see, I remember what this one looks like.
Did you want us to print out Old Faithful?
No, you don't really have to unless you want to. You can just follow along. It depends on whether you feel like you need a printed copy of it or not. I'll post the answers to the drawing grass worksheet, but I won't ask you to turn it in. It'll just be for practice.
When will the, Disney movies worksheet be due?
Next class period, because that way I'll have a chance to check and make sure that you're doing that right before we actually have a test on it. Okay, so I've got the Disney movies worksheet up here. Now I'm going to cheat a little bit. I'm going to actually copy and put it in. Well, I thought it was going to, maybe not. I'll try to. Let me see if I have a Word copy of it. Because I want to help you actually see an extra example of how to do a worksheet and do a histogram in Excel. Well, as a matter of fact, it looks like I've already got it. Yeah, I've already got it here. But I'll show you how I did what I did. So I'm going to leave that there for a second. Okay, here's what we want to do. And you can use your calculator, you can use Excel, you can use whatever you want to actually sort the data. I'm going to leave that up to you. I'm going to use Excel because it's more convenient, but you can load this data into your calculator. The thing is, if you're going to load it into your calculator, you don't want to load it into 1, 2, 3, 4, 5, 6, 7, 8 lists. This is all one set of data. So you put all of that data in list 1, or all of it in list 2. You don't put it in 8 different lists. Does anybody else need one that didn't get it? Here comes one. Anybody else? Okay, here's the data that we have. what we want to do is we want to use these sample measurements. They are a sample, it's not a population. It's a random sample of height measurements in feet from eruptions by the Old Faithful Geyser, which is in Yellowstone National Park. And the maximum height ranges from 90 to 184 feet. So it's not the biggest or most regular geyser in Yellowstone, but it is the biggest regular geyser. Some of the others don't erupt as often. Some of them don't erupt and have as big an eruption. So we look through these measurements, and despite the fact it tells us that the heights go from 90 to 184, we're going to deal only with the sample measurements that we have. We're going to base everything that we have on the sample measurements. So with that simple random sample, we're going to use the given data, not the problem statement itself, but the data that we have from the sample, to create a frequency distribution consisting of 6 classes. And what that means that we will need to do then, and we've done this before, this is just a way to get into Excel from here, is we're first going to use the idea of class width with this data and decide what the class width is going to be. So here's the worksheet with the data. And for class width, we need first to find the range. Which means how far is it between the lowest measurement and the highest measurement. So if you look at the data, it looks to me like the lowest measurement is 95. And maybe the highest is 150. Does anybody see anything higher than 150 here? If you're not sure, you can put it in Excel or your calculator and sort it from lowest to highest. But I'm pretty sure that that's right. It goes from 95 to 150.
Great.
So we take the range, and then we divide it by how many classes we want to make. And it says we want to make a frequency distribution of 6 classes. So we're going to take that 55 and divide it by 6. And we get 9.166666 repeating. But we're always going to round that up. So we're not going to call that 9.16, we're going to call it 9. Instead of calling it 9.2, we're just going to round it up to the next whole number because our data is all whole numbers. So we're going to go ahead and round this up to 10. And that makes it kind of nice because it's easier to figure out our increments here. So the class width is going to be 10. So we start with class limits, and the first one's going to begin at 95 because that was the smallest. Yes, the smallest is 95. And we're going to add 10. 95 plus 10 is 105. And then add 10 again, that would be 115. And then add 10 again, and that would be 125. And add another 10, and that's 135. And then add another 10, and that's 145. And that's good because our largest measurement is 150, and it will fit in this last class then, because it's more than 145. Now this class, if it goes from 95 to something, and the next number that the next class begins with is 105, then the upper class limit here must be 104. because we don't have any decimal values. If we had decimal values, then we would have to take that into account, but these are all whole numbers. So this one goes from 95 to 104, and because the class width is 10, then we can get the upper class limits just by adding 10 to the first upper class limit. So this would go to 114, this would go to 124, this would go to 134, 144, and 154. So there's our class limits. And then we just have to go through and determine how many we have in each class. So we're going to have to go and count all the ones that are from 95 to 104. And you can do this with your calculator more efficiently if you sort it and count that way, or put it in Excel, sort it and count that way. But we'll do it from the raw data because you don't always have a calculator handy. So we'll just work from the raw data. How many measurements are from 90 to 104? Well, not that one. No, not that one. You can go through pretty quickly. And everybody agree it's 2? Because none of these go in there. None of those go in there. None of those. Except this one. And this one. And all the rest of these are more than 104. So the frequency of the first one is 2. And then how many from 105 to 114?
We can't see any last column.
Let's speed them over a little bit.
3.
Yeah, I see, let's see, 95 to 104 is 105 to 114. There's 1. Two, and then the one right under it makes 3. And then how many from 115 to 124? There's 1, 2, 3, 4, 5, 6, 7, 8, 9. I missed that one, that makes 10, is that right? And then 125 to 134. And at this point, I'll take y'all's word for it, it's 12. What about the next one?
9. 4.
And then 4. That's pretty tedious, honestly, to have to go through doing it that way. And when I get to Excel, I'm going to show you a much faster way to do that. But what I want to make sure is that when I add up my frequencies here, that the sum of the frequencies has to be the same as the total number of pieces of data that I have. And this is 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8. I should have 40 pieces of data. So 2 plus 3 is 5. 10 makes 15, 27, 36, and 4 makes 40. So the tally of your frequencies, the sum of your frequencies needs to equal the number of the pieces of data you have. Otherwise, you have left something out or you've counted something twice. Now the midpoints for each class are the sum of the class limits divided by 2. And the reason that it will always work is because that means that class contained 95, 96, 97, 98, 99, 100, 101, 102, 103, 104. There were 10 numbers in there. So it's going to be between the fifth and the sixth number. Well, 95 plus 104 is how much?
199.
Okay. And 199 divided by 2 is, excuse me?
99.5.
Okay. Now I can do that for every single class. But if I remember that my class width is 10, I don't have to. I'll just add 10. That way I don't have to do that. Relative frequency is the frequency of that particular class divided by the total number of data pieces. So the frequency, the relative frequency here will be 2 over 40, or 1 over 20, which is what decimal value? A little arithmetic review here. That'll be 0.05. And here I don't have the luxury of just adding 10 every time because all my class frequencies are different. So the next one is 3 over 40. Oops, not 400. So it'll be 0.075. And then 10 over 40. I think I can do that one by myself. So that will be 0.25. And then 12 over 40. And I could do that one by myself, but I'm going to let the calculator do it. And that will be 0.30. And then 9 over 40, which would be 0.225. And then 4 over 40, which is 1/10 or 0.10. And if you add up the fractions, you should get 40 over 40, and if you add up the decimals, you should get 1. The sum of the relative frequency should always be 1. Okay, because that's 100% of the data. That's all of the data. Cumulative frequency says how many are in this first class no more than 104. Well, there's only 2. But if I said how many are 114 or less, that would be these 2 plus these 3, which would be 5. And if I said how many were 124 or less, that would be these 2, these 3, and that 10, which would be 15. How many were less than 134? Well, that would add another 12, so that would be 27. And then how many were less than 144? 36, and then the remaining would mean that I would have 40. So the sum of the frequency distribution is the same as the highest cumulative frequency. Those would be the same. Okay? It's important to know how to do this. And the reason it's important to know how to do this is because what we want to do is to be able to take this data and make a histogram. And making a histogram is a little bit more involved than making a bar chart in Excel. If you've done any of your Excel labs, making a bar chart's not too tough, but making a histogram takes some extra steps. So the way that I got this was that I took all of these data and basically I was just copying and pasting. I cut them out from there and pasted here, and then I cut all the rest of these out and paste them here. And I cut all these extra ones here and paste them there, and then cut all of these, paste them there, and cut these three, and pasted them underneath, and then cut these two, pasted them underneath, and then finally cut those last 5 and pasted those on the bottom. So that was how I actually got the data that I have in column A there. Was I just copied the table out of the document, pasted it into Excel, and then manipulated it using cut and paste until I got them all into a single column. You can copy data from one column to another. You can put the borders around it or not as you choose. So I put all borders around that, but I don't really care so much about this. So, you know, I did the whole column, it doesn't matter. You can erase data by highlighting the column and just telling it to delete the data, and it'll do that. So, you know, most of the commands in Excel are pretty intuitive. What I want to do now, though, is I want to actually show you how you can sort the data just like you did in the calculator. So if I highlight column C, which is all of the data, and I tell it to sort from smallest to largest, it just automatically does it, and I can see the results immediately. And the reason that that's handy is because if I go over here and I want to build my frequency table, these are my class limits. And in order to be able to see everything, I'm going to widen that automatically. Or I can enter my class midpoints, but we'll leave that for a few minutes. What I want to do is I want to actually do my frequencies. And since I'm going to put the midpoints here, I'm going to label it, but I'm not going to calculate them yet. So it's easy to say, well, okay, how many are from 95 to 104? Well, the first number that's bigger than 104 is that 110 there. In fact, so y'all can see it better, I think I'm going to increase the font to this to about 16 so you can see better what I'm doing. So how many of these are bigger than 95 but less than 104? Well, it's easy to see, it's the first two. And down here at the bottom it says the count is 2. So it actually counts for me. Now, in order for me to remember that I did those, I'm going to actually fill those cells with a color so that I know I've already counted those. I don't care what color you use whatever color you want to. But I know that there's 2 of those. So my frequency here was 2 for that one. And of course I could just type them in off my sheet, but if I'm starting from scratch, it's easy to get it right here off of Excel. The next group goes from 105 to 114. Well, 115 is too big, but all these other numbers should be in there. So that tells me down here at the bottom that there's 3 of those. And I'll make them green, just to set them off. And then the 115 to 124, well, 125 is the first number that's bigger than 124. So I'm going to count these. And it says there's 10 of those.
You missed the 120.
No, it's there. It really is there. It doesn't highlight the first one.
Oh, okay.
Okay? You can see the green border around it, but it doesn't turn it gray. But it says there's 10 of those. See there, it looks like it left out the 115, but it didn't. And we'll make that one blue, just to make it different. And then the 125 to 134, well, let's see, the first one that's bigger than 134 is this 136, so I'll start there. And it says there are 12 of those. And then 135 to 144, well, 148 is too big, so 140 up to that point. And it says there's 9 of those. And then the remaining goes in that last group, and there's 4 of those. So if I did everything right, I should have all 40 of my data pieces. I know there's 40 of them, because if I highlight, click and drag the whole entire column, it tells me the count over here is 40. So if I add the frequencies up, it says there's 40. Now that's not part of what my table normally has, but I'm just double checking to make sure I didn't leave anything out. Now, since I already know my midpoints, I'm going to go ahead and type those in. But just to show you that if you didn't know what they were and you wanted to actually use Excel to calculate them, I know that that first midpoint is equal to, and I need parentheses, 95 plus 104. And I want to divide that by 2. It says I'll put a Z in there. Well, let's cancel out of that, take that Z out of there. That was a typo. It says the first one's 99.5. And since I know my class width is 10, the next one is 109.5, 119.5, 129.5, 139.5, 149.5.
Do you have to use a class width on all of these?
Hmm?
Do you have to use a class width on all of these?
To calculate your midpoint? No. The fact that you know that 95 to 105 is 10 and 105 to 115 is 10, the class width is the same all the way down. The only reason I calculated the first one for you was to show you that that's, you know, you can get Excel to do simple arithmetic for you. You don't have to hold out your calculator and use Excel. Excel has a built-in calculator. And I could fill in the rest of the table, but I want to make a histogram, and I don't really need the rest of that table to make a histogram. All I really need is what I've already got. So in order to make a histogram, the first thing I'm going to do is to highlight only the frequencies. Nothing else, just the frequencies. Just the counts. And then I'm going to insert. And Excel is not real smart. It calls a bar chart something that has the bars to be horizontal. What we really want is a bar chart, but we want the bars to be vertical. Okay, we want the bars to be vertical. So after I've highlighted these frequencies, I can choose any of these, but since we know three-dimensional figures can be deceptive, we're going to choose two-dimensional figures. And there is the beginning of the histogram. And notice I said it was only the beginning, because it's not a histogram just yet. There's some things wrong with it. First of all, it doesn't tell us anything about what this is about, so I'm going to go ahead and change the chart title. My favorite way to change the chart title isn't to go into any of the tools. I just type it in myself, so I highlight where it says chart title, and I'm going to call this Heights of Old Faithful Eruptions. Because that's what it represents. The other problem that I've got here is that each one of these bars doesn't represent 1, 2, 3, 4, 5, 6. It actually represents these class limits. So with my chart highlighted, notice up here chart tools gets lit up. And there's two of them. There's design, there's format. And if you can't find what you want on one, chances are it's on the other. On design, what I would like to do is I want to select the data, and notice here it's got checked 1, 2, 3, 4, 5. I don't want it to use 1, 2, 3, 4, 5. I want it to use the class limits. So what I'm going to do here is I'm going to click Edit, and I'm going to choose my class limits and tell it OK. And notice now my bars are labeled by the class intervals, not 1, 2, 3, 4, 5. I could label it by the class midpoints the same way. I would just go over there and click that same, select data, and click Edit, and tell it, no, use these. And now it uses the midpoints. It uses whatever I tell it to.
What do you do after you hit the edit button, like where it says edit series? What do you put in there for the series name and the series value?
You click and drag whatever cells that your labels that you want it to use are in.
Okay.
Like for example, and I'll just switch it back so you can see. Select data, and what you want is the horizontal axis. Don't mess with the legend. Don't mess with this part because it's looking at the frequencies. What you want it to change is you want it to change just the axis titles, the horizontal axis titles. So if I wanted to use class limits, then I tell it to use those. And you can use either one. There's nothing wrong with either one, whichever way you want to do it. The other thing that I really don't like about this is that there is not a gap from 114 to 115. The next number after 114 is 115, and they should come together at 114.5, and these don't. So what I'm going to do is I'm going to right-click on any one bar. Doesn't matter which one. Once you right-click on one of them, they all light up. And I'm going to tell it to let me format the data series. And notice it says the gap width is 219%. I don't want there to be a gap. I want no gap. So I'm going to change that. Now I'm just scrolling, but if you'll watch, the bars are getting wider and wider and wider. I could have just put in a 0 and it would have done this instantly. And now they're touching. So I need those bars to touch. But now I've created another problem for myself. Now I've got a giant blue blob. All my bars are running together. I can't tell one from the other. So what I need to do now is say, could you please put me a line around those? So I'll click on those bars again and click this, and it says no line or automatic line, and automatic is that it's using white to outline things, which doesn't show up very well. So I'm going to say, would you please use black so I can tell the difference between the bars. Okay, don't use black then, fine. It's being hateful. You can actually do it from right here. There we go. And it puts black borders around all of it. If you wanted it to have yellow borders, you can change the color of the bars themselves. If you highlight that and you want to change the color of the bars themselves, change the fill and tell it to pick a different color. So it's up to you. You can make all the bars different colors. It doesn't matter. All you have to do to make them different colors is you just select one of them. Now I can make that particular one yellow, but usually with a histogram you make them all the same color. The only thing remaining is, that tells me something about the heights of Old Faithful eruptions. It labeled the bottom, but I don't know how they measured those. And I've got these numbers on the side, but I'm not sure, is that counted by ones, is it counted by tens, is it counted by hundreds? So I probably want to add some axis titles, either horizontal or vertical or both. So I'll do the primary vertical, and I'm just going to call that frequency. In fact, I'm not going to, I'll be more descriptive than that. Number of eruptions. And it changes the title of that axis to what I told it to. I can make that bigger by going up here to where the font size is and tell it I would rather that be 16 so that I can read it better. I can tell it I want it to make the title a bigger font so that I can read it better. I would also like to do the horizontal axis, and that is height of eruption in feet. And then I'd like for that to be a little bit bigger also, so I will tell it to make that in a larger font. And now my chart actually is very informative. Okay? Now if I had just left it alone at the beginning and just changed the titles for each of the bars, I would have had a bar chart. But bar charts are for categorical data. They are not for numerical data. The difference in bar charts and Pareto charts and histograms is that histograms are for numerical data only. It has to be either interval or ratio level data. It has to actually be quantitative data. If it's a bar chart, it's qualitative data, and you only want counts, and those categories do not touch. They do not run together because they're not numerical. This is actually a lesson on how to do the lab on histograms. And I'll close that, and there's a perfectly good histogram. And if I wanted to, I could copy it and paste it into a Word document and discuss what all of this means, which at one point in the class is something you're going to have to do. you're actually going to need to be able, once we get through the first test, after the first test, we're going to collect some data that's going to be the basis for your project. And you'll have 2 or 3 more labs to do after that, and those labs will make up the bulk of your project. The last thing you'll do is take a Word document and explain what you found in your lab, and then paste in your charts and things from Excel. Does anybody have any questions up to this point? Yes?
I need you to come here for a second, show me.
Okay, let me pause it. Everybody else can take a break. Okay, so we're going to begin chapter 3. We have been doing charts and graphs, and if you hadn't realized it yet, I have actually done one of the labs. I made a real quick short PowerPoint. I probably will do a PowerPoint of the examples of the other labs for you and post those up there too if you go to the Integrity Lectures. I can do those in about 5 minutes from my office. They don't take long at all. So I'll try to go through the sample with you. I've had questions from several people about, my version of Excel is not the same as yours. Yeah, I understand, because my version of Excel in my office doesn't match the version of Excel that I've got at home. So some of the buttons are in different places. If you get really stuck, send me a message, tell me which version of Excel you got. Do you have Office 365? Do you have the newest version of it? Are you still using Excel 2010 or 2013, or what are you using? And I have a computer that has all the different versions on it, but it just depends on which version you got, because some things don't look the same. So if you have trouble with any of the labs, just let me know, and I'll try to do a Integrity and specify which version of Excel that it uses for you. Because I had a little bit of trouble myself using the newest version. Okay, this is the handout that you're going to need for the notes that we're going to begin today and finish on Wednesday. And then the last half of the class on Wednesday, my goal was for us to have a little bit of time to review or do an activity to help us review to get ready for the test. So, Chapter 3, measures of center, measures of variation, measures of relative standing, and box plots. Sounds like a lot, but it's not really any of it hard to do, and most of it we won't do by hand, and we will do almost all of it using either Excel or the calculator. Most of it actually probably the calculator. So what Chapter 3 is about is statistics for describing, exploring, and comparing data. And these are what we're going to look at. Measures of center, measures of variation or variability, measures of relative standing, and box plots. Those are the 4 things that we're going to look at. The measures of center and all those others, what we're doing right now is we're doing descriptive statistics. Chapter 2 was also descriptive statistics. You learn to summarize or describe important characteristics of a known set of data. Inferential statistics doesn't actually start until Chapter 6. And that's when we'll use sample data to make inferences and generalizations about a population. So right now we're learning the basics. It's like if you were back in kindergarten, first grade, when you first learned how to make letters, and then you learn how to put the letters together and make words, and then you put the words together to make sentences. So we're kind of building on this, and you have to get this part before you can go on to the next part, which is eventually taking those sentences and putting them together and writing a paragraph if you were in an English class. So the measures of center, what are they? Mean, median, mode, and mid-range. I will tell you up front the mid-range is next to useless. And as we get to that, I'll explain to you why it's next to useless. The mean, the median, and the mode are all very useful. But it's basically measures of center or the value at the center or the middle of a set of data. What you think of as the average is actually what we call in statistics the mean or the arithmetic mean. The mean is where you take all of the numbers in the set of data, you add them up, and then divide by how many numbers you have. The median is where you have to rank order the data first, put it from lowest to highest, or highest to lowest, and then find the number that's in the middle. The mode is the number or the value that shows up the most often. The mode is the only one that you can do with non-numerical data. You can use categorical data and find the mode. In fact, that's part of the reason you make a Pareto chart, is because the mode in a Pareto chart is going to be that first bar. It's going to be the tallest bar. The mid-range, as I said, it is almost useless because it only looks at two values of the data, the lowest and the highest, and it finds what's dead center between the two of them. So it really doesn't tell you much. The arithmetic mean, which we will call simply the mean, is the measure of center obtained by adding the values divided by the total number of values. It's what most of us, as I said, call an average. If you're going to look at formulas, you're going to have to think about what notation means. X is the variable usually used to represent the individual data values. N represents the number of data values in a sample. Capital N represents the number of data values if the data set you have happens to be a population rather than a sample. Little n is for a sample because the sample is littler than the population. X with a line over the top of it is pronounced X bar. Some textbooks call it bar X, but X bar or bar X is interchangeable. And it stands for the mean. The way you find the mean of a set of sample data values, again, this is a sample, it is a statistic, is that you add up the X's and divide by how many X's you had. In other words, you add up that symbol there that looks like a kind of a backwards 3 or a backwards E is called the sum of. It is the Greek capital letter sigma, and it means add them all up. So it says add up all of your data variables, all of your values, and divide by how many values that you had. Notice that the only difference between the sample statistic X bar and the population parameter mu is the symbol you use to represent it. You calculate both exactly the same way. So all you're indicating to me when you use X bar is that your information came from a sample, and if you use the symbol mu, you're indicating to me that the data that you worked with was from a population. And the mu actually just looks like a U with a long tail on the front end of it. It actually is the Greek letter M. And the Greek letter M is pronounced mu, and that is a lowercase mu. Now here's some advantages of the mean. It's relatively reliable because it takes into account every single number in the whole entire sample of data, or if you have the population, takes into account every single value in the population. Means of samples drawn from the same population don't vary as much as other measures of center. But the big deal is that it takes every single value into account. Smallest, largest, the ones that show up the most often, the ones that show up less often, it takes every single value into account. The disadvantage is that it's very sensitive to every data value, which means if you have a large number of a certain value, then it's going to be influenced toward that number. If you have an extremely small data value that's really much smaller than your other data values, it's going to cause your mean to be less because of that small data value. Or if you have a mean that you're adding up the mean and you have a very large data value that's very far away from the higher end of your data, what we call an outlier, then the extreme values can cause the mean to vary a lot. So it is not a resistant measure of center. It can't overcome the influence of what we call outliers, odd data values that are extremely high or extremely low. The median, on the other hand, is not affected by any extreme values. It is a resistant measure of center because it is exactly what it says it is. I'm in the middle of these 25 numbers and I'm not moving. If you change the lowest to something else, I don't care. If you change the highest one to something else, I don't care because I'm standing in the middle of all of them and I don't care what the low and the high are. That really is what it is. The middle value, when the original data are arranged in order of increasing or decreasing magnitude, is the median. The mode is the value that occurs with the greatest frequency. It's the one that has the highest count. Data sets can have one, they can have more than one, or they can have no mode at all. All of them can be different. Bimodal is the only one we talk about when the data set has more than one mode. We will say that a data set is bimodal if it has two numbers that show up in equal frequency of times, and both of them are the highest. Multimodal means more than two data values occur with the same frequency, and multimodal data tells you that probably the mode is just not a real good measure of central tendency. Because one of your modes is going to tend towards the lower numbers, one's going to tend towards the higher numbers, and one's going to be somewhere in between the first two. So it's not really going to be very representative or informative. No mode means that none of the data values are repeated. So the mode is the only measure of center that can be used with nominal level data, categorical data. So here's an example. We have 5.40, 1.10, 0.42, 0.73, 0.48, 1.10. The mode of the first data set is 1.10. Why?
Because it happens more than once, and none of the rest of them.
Right, none of the rest of them happen more than once, but 1.10 happens more than once. Okay? Is it a good measure of the center of this data? That's right, not really, because it's higher than any of the others. Other than the 540, that's the only data value that it's not higher than. The others are all smaller than the 110. So it's not particularly a good measure of what we call center. Example 2, we have 27, 27, 27, 55, 55, 55, 88, 88, 89. What is or are the mode or modes?
27, 55.
27 and 55. Because they both show up 3 times. Are 27 and 55 necessarily a good measure of the center of the data? Well, 55 might not be a bad one, but it is kind of between 27 and 89. But 27 is the lowest value of the data. And it's a mode, so it isn't a measure of center. I mean, it is a mode, it shows up a lot, but it's not necessarily a measure of center for that reason. 1, 2, 3, 4, 1, 2, 3, 6, 7, 8, 9, 10. Does that set of data have a mode? No, that has no mode. So with that, we have talked about the mode, and we will pick back up and talk about the mid-range next time. Okay? And we will finish chapter 3. If you have questions, if you need anything, let me know. Yes.
So you need these?